Hello, everybody. This is Gordon. This is the beginning of a set of problems. Call it Introduction to Vectors. Vectors, of course, are quantities which have direction as well as magnitude. We have relationships here over on the right-hand side that will help us through these problems, defining the way to add two vectors A and B, how to break a vector down into components, the component in the y direction and the component in the x direction. That being our cosine theta, theta being the angle that the vector makes with the horizontal. The magnitude of r is the sum of the squares. We're talking about the Pythagorean theorem here. And then relationships from trigonometry for theta between the sides and the hypotenuse. First question, which of the following are scalars and which are vectors? Basically applying the definition, vector being something that has direction as well as magnitude. And so keeping that in mind, kinetic energy will be a scalar. Centrifugal force, a vector. Electric field intensity will be a vector as well. Charge, of course, is a scalar, as well as entropy. Temperature, 30 degrees as a magnitude. It has no direction, so it's a scalar. And work, as well, is a scalar. Gravitational potential has magnitude but no direction, and so it's a scalar. Shearing stress is a vector. And frequency, like 20,000 hertz, is a scalar. First problem, man walks eastward for 5 miles, then northward for 10 miles. How far is he from his starting point? What direction could he have headed to walk directly there? Excuse me, I apologize for the condition of my voice. Here we can consider the vector A to be 5 east and the vector B to be 10 north. It's always helpful to draw a picture when we're doing problems like this, to put something on a set of Cartesian coordinates. So with an xy axis, we have A being 5 east and B being 10 north. We're looking for this vector. The resultant one, we're looking for the magnitude of that. That'll tell us how far he traveled. We're going to use the relationship. The magnitude of r is equal to the sum of the squares of the x and y components. So r will equal to the square root of 5 squared plus 10 squared, equal to the square root of 25 plus 100, which is the square root of 125, 125. And the numerical value for that is 11.2. So the man walked 11.2 miles. We know that r is now 11.2, so we can use any of the trig relationships we have to determine what theta is. Using the cosine, we have cosine theta is equal to adjacent over hypotenuse, so that's going to be 10 divided by 11.2. So theta will be the inverse cosine of 10 divided by 11.2. Numbers go into the calculator, and theta comes out to be 26.7 degrees. Our third problem, if 10 pounds of force is used to pull a wagon with a handle that is 30 degrees above the horizontal, question is, what are the horizontal and vertical components of the force? In other words, break the vector down into x and y components. We're looking for f of x and f of y there. So f of x, using the relationships we have over on the right-hand side, where f in the x direction, the component of the direction in the x direction is going to be f cosine theta. And here, theta is 30 degrees. Component of f in the y direction is going to be f sine theta, or f sine 30. Plugging in the numbers, f, of course, is a numerical value of 10. Cosine 30 is 0.866. Multiplying the two together, we get 8.6 pounds of force. F in the y direction is 10 times the sine of 30, 0.5. And so the component of the force in the y direction will be 5 pounds. Problem number 4, a car with a mass of 1,500 kilograms is on a hill. Well, first we need to know what the force is. Mass, of course, is not a vector, but weight is, and weight is mass times acceleration. So we have 1,500 kilograms times 9.8 meters per second to come up with a weight of 14,700 newtons. And we can draw our picture. We know that theta is an angle of 20 degrees. The car is being pulled toward, the weight is directed towards the center of the earth. And that force, the weight, can be broken down into two components. In the x direction, perpendicular to the road or the ramp that the car is on, and the y component will be parallel to the ramp or the road. As before, f of x is equal to f cosine theta, so it's going to be the 14,700 newtons times cosine of 20 degrees. Numbers go into the calculator, and we come up with 5,027 newtons. F in the y direction, the 14,700 newtons times the sine of 20. Numbers go into the calculator, and the answer, 1,381 newtons. And the problem is done. Last problem, a little bit bigger than the other ones. Two tugboats towing a ship. Each exerts a force of 6 tons. The angle between the two tow ropes is 60 degrees. We're asked to find the resultant force on the ship. As always, draw a picture. The dot represents the ships. And here we have two tow ropes, each exerting a force of 6 tons on the vessel. The angle between the two of them is 60. We'll call the upper one A, the lower one B. The angle that each makes with the horizontal or the x-axis is going to be 30 degrees. And we use the relationship that we have in the other problem, where A in the x direction and A in the y direction, given by, well, a little bit more of a picture, just to make sure that we understand what's going on, B in the x direction. This is important to do because it alerts you to the fact that B of x might be the same magnitude as A of x, but it's in the opposite direction. And so those two forces will cancel each other out, as we'll see. A of x is going to equal 6 cosine 30. A in the y direction is going to be 6 times the sine of 30. B in the x direction is going to be the same as A in the x direction, 6 cosine 30. And B in the y direction will be 6 sine of 30. But again, it's in the opposite direction, and so it's going to have numerically a negative value. A of x, 5.2 tons. A in the y direction, 3 tons. B in the x direction, 5.2 tons. B in the y direction, or the y component of the B force, is going to be negative 3 tons because it goes in the opposite direction of A of y. And so the resultant force is going to be, using that big equation that's up on top, summing the x components and then summing the y components. We're asked to find a force, so we're looking for a vector. It's going to have magnitude and direction. A of x we'd calculated to be 5.2 tons. B of x, or B in the x direction, is also 5.2 tons. The y component of A is 3 tons. The y component of B is negative 3 tons. So our result is 10.4 tons. That's the magnitude, and the direction is going to be in the direction of the y-axis, the x-axis, my apologies, in the direction of the x-axis. And because I was negligent in the beginning, I'll take the time now to draw on the x and the y-axis just to make it clear what I mean. So again, the result, 10.4 tons in the direction of